Hello everyone, welcome back from lunch. Try not to be too drowsy during this session. I'll try and keep it lively. Let's start with a question. What do you get if you cross this with this? I think we all know what the answer is, and it's obviously this. When I saw that that was the new album cover, I thought, this is just too perfect. I have to include this. Okay, so seriously, I've got a talk in 3 parts for you. The first part, I'm going to talk just a little bit about Kitura and what we've been doing over the last year in that ecosystem. In the second part, I'm going to talk more generally about microservices and some of the considerations to take into consideration when you're building them. And then in the third and final part of the talk, I've got a demo of a new development tool for writing microservices, which we think hopefully will make writing microservices in Swift much more pleasurable. Has everyone enjoyed enough Taylor Swift? Okay. Okay, so what's been going on in Kitura over the last 12 months? I'll just give you a quick update. So we've been making kind of steady incremental releases over the last year. So I'll talk about some of the highlights and some of the things that you might not previously been aware of in those. So for end of last year, we released a major version of our database libraries, database abstraction layer. So one of the key features of that is that the API is now fully async. So why did we do that? Well, one of the things Logan mentioned in his talk this morning was that the Server Swift working group is producing database libraries themselves, and all of those are async, so we need to be able to connect our stuff up to those. So doing that refactoring was a big part of why we did that. Kitura 2.6 came just before the end of the year, and this was mainly to do with baking Codable more into the framework than it had been previously. Earlier on this year, we released a new library called BlueECC. So ECC is elliptic curve cryptography, which is becoming much more prevalent and more popular. A lot of people were asking, can I do elliptic curve crypto in Swift? And there wasn't an answer for that until we wrote this library. We also built it into our JWT library, because one of the most common use cases for elliptic curve is when you're actually doing JSON web tokens. So we baked that in. Kitura 2.7 came out kind of end of the spring, kind of coincidental with Swift 5. So the major change there was that you now have the option to run Kitura using Swift Neo version 2, which is nice. Following on from that, Kitura 2.8, we started to adopt some of the packages that were coming out of the Swift Server working group. So one of those is Swift Log, which is obviously the abstract logging API. I think Logan mentioned it this morning. And finally, just last week, we released Kitura 2.9. Again, this is probably the highlight is the Swifty Request 3 in the middle there. So Swifty Request is our library for making outbound REST requests from your Kitura app. And the main change in version 3 is that is now built on top of the async HTTP client, which was written by Artem, who's sitting down there. That's great to adopt that tech as well. So that's kind of a roadmap of where Kitura has been going over the last year. One other thing I just wanted to make people aware of, because I don't think the message has kind of got out there, is that we've also written a library for interfacing with Kafka. Quick show of hands, who's using Kafka? Yeah, kind of about half a dozen hands. So what's Kafka, if you haven't heard of it? It's an event streaming platform. You can consider it a bit like a pub/sub message system. So you kind of subscribe to a topic and you receive messages on that topic. But the key thing about Kafka is that it stores the records in a durable way. So in most pub/sub systems, if you missed a message, if you weren't up when it was sent, you can't receive it. But with Kafka, because they're durable, you can actually rewind and you can replay historical messages, which is a really interesting use case. Kafka is super popular, and people wanted to be able to use it with Kitura, so we have built a library to do that. It does pub and it does subscribe, so you should check that out. If you want to try it out, it's really easy to try out even on your local Mac. You can get Kafka. It's pretty, I mean, it requires Java, so obviously it's like pretty heavy on resources. But you can install it through Brew, which is nice. It uses Zookeeper for the distributed nature of it. So that's pretty easy. What does the API look like? Well, it's pretty simple, really. You can see it here. So we have some kind of config, and you can see it says auto reset beginning. So that means we're going to replay all the historical records from the beginning of time. So then we create a consumer. We connect to our broker. We subscribe to a topic we're interested on. So this is like just an array of strings. That's how Kafka does them. And then we can loop calling poll on the consumer to consume the records as they come from the Kafka broker. Because we're built on top of the C library, we're kind of limited by the API they give us, and the only thing they offer is polling, so that's what we've got. It does mean this is probably quite difficult to integrate into apps that are built on Neo or Vapor, but it's there. So if you've got a use case for Kafka, maybe some batch job where you just want to do ETL, like extract something, transform it, load it into another database, maybe it'll be useful for you. So I just wanted to let you know that that's out there now. We've revamped the Kitura website over the last couple of months, which has been a big help, I think, to people who are picking up the framework for the first time. So if you go to the docs page, there's now a full set of guides for each of the features in the framework, so you can learn about them. We have a full set of tutorials as well, so these are more kind of workshop type things. In fact, the bottom right one is the workshop I ran yesterday, so if you happen to miss that, it's all up on GitHub, you can do it in your own time. And finally, of course, we have API reference documentation for all of the packages in the framework. So that was good. There's obviously our blog, which is now on the Kitura website. Previously, it was off on some random part of IBM.com that no one could find. So the blog is on the website now, and also some videos of previous talks and things like that. So that's a kind of brief update to what's been going on in Kitura. If anyone's got any questions about the framework, feel free to talk to me about that afterwards. But I wanted to kind of move on to the meat in the middle of the sandwich, which is to talk more generally about microservices and some of the considerations that people have when they're building them. So actually, what does cloud native even mean, right? So if you were going to look up, like, what does cloud native even mean, you might go to something like the Cloud Native Computing Foundation. So they're a cross-industry body which is kind of shepherding a lot of important software projects. And if you go to the CNCF and say, like, what are the key technologies that make something cloud native, or you need to learn about to understand this, they have what they call the Cloud Native Roadmap. So I thought that was a good place to start, and it really made things simple. I'm not joking, this is on their website. This is all of the open source projects that they say are part of the cloud native ecosystem. God knows where you start with this stuff. So I'm going to try and pick out a few topics in this which I think are actually really important to know about. And when people are talking about cloud native today, really the key project is Kubernetes. And you can see it on the left-hand side, about a third of the way down. There's a tiny wheel. OK, so let's have a look at Kubernetes and what it is and why you might care about it. So hands up, who is running Swift today in a Docker container? Yes. Who is orchestrating those Docker containers into some kind of homogeneous system? Let's call it a cluster. Yes, OK. And who is doing that with Kubernetes? Fewer and fewer. OK, so Kubernetes is it's a container orchestration system, and it is taking over the world. So actually, I added this slide last night because I saw it on a tweet. So Sysdig are they do like cloud native monitoring, and for the containers that they are monitoring, where are they deployed? So I think even a year ago, Kubernetes would not have been that high. Things like Docker Swarm, Apache Mesos, they've really perhaps not have had their day. Kubernetes has won So what is Kubernetes and why is it run? Why is it one? Well, it's a container orchestrator. What that means is it can provision, manage, and scale all your containerized applications. Nice. I say containerized, so it can run Docker containers, but Docker isn't like the only game in town. The actual image format of a Docker container has now been standardized, so there's other ways to run containers apart from using the Docker engine. But just running containers on its own isn't enough. Containers need to interact with other containers. And so you need to be able to mount volumes in so you can access like storage. You need to connect them together using virtual networks. You need to be able to inject things like database passwords into the process. So Kubernetes lets you do all that and much more because it's an extensible system. In case you're wondering where the silly name comes from, it's from ancient Greek, where apparently a Kubernetes was a helmsman. That's where the logo comes from. It's not a very good name for a very important project, I think. Okay, so how does it work? What's Kubernetes actually look like? So really at its core, all it is a distributed database. So etcd or etcd is the database, which is distributed and fault tolerant, so you can run it across a cluster and it replicates itself. And then on top of the database, you have watchers and controllers that just react to changes in the databases, So the controllers are really what makes it Kubernetes. Let's have a look at a picture. So on the left-hand side, you have the client or the user. This could be someone in the CLI, or it could be maybe some job in a CI system, which is kind of saying to Kubernetes, I want to change the state of the system. And so you send a message to the API server. That just happens over REST. And then the API server stores whatever the request was in the database. It's etcd. And as a result of that, the watchers and controllers which are looking at the database say, oh, something's changed. I need to change the state of the running cluster. Could be a new node is added, could be a new container gets run, whatever. So the database is holding the desired state, and the watchers and controllers attempt to make the reality of the cluster match what's in the database. So this is what's known as a declarative system. So the database is a source of truth. It's like it's holding what the world should be, and then the rest of the system is trying to make the state of the world match that. So let's have a look at how something might actually get deployed onto Kubernetes. So let's say we're interacting with it through the command line. So kubectl is the command line. You say you want to run a new program in Kubernetes. What the client will actually do is it will convert whatever you type on the command line into some YAML, and it will then save that YAML into the API server and store it. And the watchers on the right-hand side will react to that. So let's say you're creating a new set of containers, 5 replicas. So the replica set watcher will kind of say, oh, we need 5 new replicas. That means I'm going to have to spin up 5 new pods or 5 new containers to actually execute those. The scheduler will then assign them across the nodes and run them. And there's a component called the kubeproxy, which manages the network traffic. So this is not a simple system, as you can immediately see. If you want to get your software running in this, you kind of have to make sure that your software is Kubernetes enabled. And I'm just going to talk a little bit about what kind of requirements it places on the software that it's scheduling. So the first thing is some kind of health. So one of the great things about using an orchestration system is it's going to manage the containers for you. If your container crashes for whatever reason, it's going to restart it. So how is it going to do that? Well, it places a requirement on the container that it publishes an HTTP endpoint on /health or whatever you configure it to be. And basically, it's going to ping your container every 5 seconds or 20 seconds or whatever you configure. And if it doesn't reply or if it times out, it's going to restart it for you. So how can you implement that in an app? Well, I'm going to talk about Kitora, but it doesn't really matter. It's the same principle for any app that you create. So in order to do that, inside your app, you're going to need to have some kind of health route. So in Kitora, we have a health module, which kind of helps you to integrate health checking into the different parts of your application. And then you would maybe define a route. So here we're saying router.get on /health. And then depending on the status of the server, you could respond with either up or down. You're probably thinking, well, how could you respond with down if the server is up? There's a subtle distinction here. So you could be up but not ready. Like, let's say you were waiting for some database connection pool to be initialized or something. So there's a distinction between being alive and being ready to actually accept work. Okay, so that's health. You also need to have some metrics. So let's say you want to be able to monitor the containers that are running inside the cluster. The most popular way to do that is a system called Prometheus. And actually, I think there's a guy in the audience who's been writing a Prometheus library for the Swift Server Workgroup, which is awesome. The basic idea is you have a metrics endpoint on your application, /metrics, and that publishes data about your application, and then the Prometheus system polls that every so often, retrieves the latest data, and then makes that available for analysis, graphing, whatever. So Prometheus is really the main game in town for monitoring on Kubernetes. And if we look at how you would do that in Kitora, so when you kind of generate your first Kitora application, we scaffold a lot of this out for you. So you can see that we have this initialized metrics, and then inside the initialized metrics, we have this thing called Swift Metrics Prometheus, which enables you to kind of attach the Prometheus data to the /metrics endpoint, so that can then be visualized and graphed by the application. So here's an example of the kind of thing that gets generated by Kitora for Prometheus. So you can see we've got a whole bunch of basically key value pairs. So like how much CPU is currently being used, how much memory is currently used by the application, how many requests has it handled for different kinds of routes, all things like durations of requests, and also aggregate statistics as well. So the Prometheus system will ping the app every maybe 10 seconds or so, retrieve all this data, store it in its Prometheus database, and then do aggregation based on that. So once it's retrieved it and it's stuck it in the database, you probably want to visualize that. So this is a screenshot of Kitora running on Kubernetes, I think. And this is a system called Grafana. So Grafana is the most popular way to graph data that's come out of Kubernetes. So it's really nice because you can build your own custom dashboards. They've got like loads of nice widgets. So they've got like gauges and dials and different graphs and stuff. So you can plug them all together and come up with your own personal like USS Enterprise dashboard or whatever for your cluster running in production. And of course you can use it for things like triggering notifications and paging people in the middle of the night or whatever you want to do. So let's say you want to connect two microservices together, and you want to do that in a fault-tolerant way. Let's say you've got one microservice which is going to talk to another one, and that one is going to talk to a database. What happens if requests from one microservice to another are timing out? What do you do? If a bad thing to do would be to just let each downstream request time out and then return a failure back to your users. What that means is every user is going to be experiencing the timeout. So one of the early pioneers of microservices were Netflix, and they had a very successful open source project called Hystrix, which is about a circuit breaker idea. So the idea of this is that we really don't want to make repeated calls to failed services, because what that means is we're exposing our users to that failure. What we want to do is have an alternative fallback. So maybe if a database is down, we want to return some cached value instead of waiting for the database to fail. So here's what a circuit breaker looks like. It starts off on the left-hand side in the closed state. You can consider it like an electric circuit where the switch is closed initially so the traffic can flow through. What happens when the downstream service fails? Well, in that case, we trip the circuit breaker and the switch goes to open. And in that case, we're now in a so-called fast fail state. So what that means is any subsequent requests, instead of timing out or waiting for failure to occur, we just return failure immediately. That means we can have a fallback kind of situation and return good response to our users. every now and again, you probably want to try the database again, see if it's come back, see if it's ready. So you can intermittently switch to this kind of half-open state, and when you're in the half-open state, it's kind of trying or sniffing to see, is the downstream service ready yet? And if it is, you can then go back to the normal closed state and business as usual. Otherwise, you would go back to open. So this pattern is very popular in microservices architectures because it enables you to have fault tolerance and really be able to kind of accept that in a distributed system, it is inherently unreliable. So if you're calling from your Swift microservice out to something else, you might want to consider using a system like this. Actually, part of our Swifty request library, which is built on top of the async HTTP library, is support for an integrated circuit breaker. So what you can do is define a circuit parameter, which is saying maximum time out of 2 seconds, maximum of 2 failures, otherwise we go to the fallback state. And so then when you actually make the outbound REST request, so this is just doing a get to some other URL as an example, you can attach the circuit breaker to that request, and then every time that REST request is executed in your application, you know that you've built that outbound request in a fault-tolerant way. Okay, now you want to get it actually on Kubernetes. You actually need to deploy it. What do you need to do for that? Well, you need a whole bunch of YAML, unfortunately. Okay, so first thing is a deployment. Okay, we're going to say, okay, here's a deployment. It's a microservice. We're going to give it a name. It's going to be based on a Docker image, which we've built and pushed to a container registry somewhere. We're going to make sure we always pull from the container registry, so we get the latest version of the Docker image. The container is going to be listening on a port. That's where the traffic is. We need to tell the container process what that port is, so we're going to inject an environment variable so the server can listen on the correct port for us. And we need to tell Kubernetes what it should be pinging to get that health endpoint that we saw earlier. So in this case, we've got the readiness endpoint, which is like, am I actually ready to accept traffic? And we've got the liveness endpoint, which is, am I even up at all? Okay, that's a deployment, and we're going to say we want 5 of them. So it's going to spin up 5 containers for us. But each of those 5 containers is going to be on its own IP address. How are we going to aggregate those together and make them discoverable? Well, the next stage is a service, more YAML. So a service is a higher level abstraction inside Kubernetes, so you might think of it as like a microservice, which is composed of multiple underlying containers. So here we have a name for the service that we're defining. We're giving it a node port. That basically means we're going to give it an external IP address, which is going to kind of abstract across the internal containers. And we're going to make that available on port 3000 as well. Okay, awesome. We've got 5 containers in a deployment, and the deployment is being abstracted as a service. What else do we need? Well, we need to make it scrapable by Prometheus. So we say, yes, Prometheus, please ping this service every time. The final piece is what's known as the HPA. It's a pod autoscaler. So just saying you want 5 of them isn't enough. You're going to be having varying traffic, so you're going to want to change that over time. So we're going to have an autoscaler, which is going to be watching a particular deployment, and it's going to say we've got a minimum number of replicas of 5, so 5 containers minimum, 10 containers maximum. How is it going to decide how many to have? It's going to look at the average CPU utilization on each of the containers, and it's going to look at the average memory utilization on each of the containers according to the kind of the quotas that have been assigned to that container. So we've got 3 levels of things. We've got the deployment, we've got the service, and we've got the autoscaler on top, and that is going to give us a microservice which is scalable, fault-tolerant, and happy in Kubernetes. So how do we make that happen? We change into the directory where all that YAML is, we apply all those files, we get our 5 shiny Kitura servers running, and what happens when the load changes? Well, it's going to scale that for us as well. Nice. So this is all really complicated. And I don't know if people, probably not DevOps people. DevOps people love writing all this YAML. Normal people don't. So I'm going to move on to the final part of the presentation and show you a tool we're writing, we've written, which is hopefully going to make this way easier for people. So we open sourced it just a few months ago. It's called Apsody. And it's designed to make developing microservices really easy. There's 3 key parts to Apsody. So the first part is what we call a stack. So that could be any kind of language or framework that you're interested in building a microservice. Could be Java, could be Node.js, could be Swift, right? And those, you can build those and share them as Docker images and through an Apsody hub. I'll show you how that works. We then have a command line for interacting with it, so you can create a new application, build it, and deploy it. And finally, we have a way to get them live on Kubernetes. So let me show you if I can get the demo to work. I'm not as brave as John, so I'm not going to live code it. We're going to press play, and we're going to thank iMovie that I can edit out all my typos. OK, so I've created a new directory. And what I'm going to do is I'm going to do apsody init Kitora, which basically means we're going to be developing a new Kitora application using Apsody. It's got two parts to it. It's got a template and it's got a stack. A template is like the skeleton of the application you get. And the stack is the predefined image, which has like Swift, Kitora, all the cloud-enabled stuff that we need. OK, so you can see inside here we've got a package.swift, so it's all pretty familiar. And if we do Swift run, we can build the app on our Mac. Hooray for iMovie, it goes like 8 times faster than usual. And so that will finish in just a second. And once that's happened, we'll have built the app and it's running on our Mac. OK, so it's running on our Mac. We can open up Safari. And we can go to localhost 8080, which gives us the Kitora splash screen. And then we have a few more endpoints built in to the app automatically. So the first one is /health that I talked about earlier, which shows you the health status of the app. Second one is metrics. Got those Prometheus metrics built in. We didn't have to write any of that code. And the third thing is Open API. So we actually mentioned this morning. This is a way for documenting REST APIs, which Kitora has built in. So I can actually execute a query against that health API using this kind of development tool, and it can show, yep, that endpoint is up. OK, awesome. So that was running on the Mac. What we really want to do is get things going on Linux. So I'm going to open up VS Code. And I've got a few extensions installed into VS Code here. So let's just show you what those are. First thing is SourceKit LSP. So this is the new language server protocol for Swift, which was open source. There's a VS Code plugin for that. And the second one is CodeLLDB, which is an LLDB plugin for debugging. Nice. OK, so let's see how this works. We've got the source code of the application, which was generated for us. So the main.swift is pretty simple. We have an app, we set up some routes, and then we run. Inside the application, you can see we have just the skeleton of an app. And if we mouse over a few things, we should see the awesome power of the LSP. Nice. So we get kind of the auto-completing and all that kind of stuff, which makes for a much more friendly development experience. OK, so if I hit like build inside VS Code, we've got we can do an Apsody run. So what this is going to do is it's going to build our project inside a Docker container for us. So you can see down the bottom it says Swift run, and now it says listening on port 8080 again. So if we go back to Safari, we should be able to see, yeah, exactly the same as we saw before, except this time Apsody has built it inside a Docker container for us. So this one's running on Linux. And we should be able to see a hello route, which is the one that's automatically defined for us there in setup routes. So with the app still running, let's change that and hit save. And you will see down the bottom, Apsody spots that, rebuilds the application, and woo, hot code reload. So that's nice, kind of iterative development experience for us. Apsody stop, and we can stop the container. Now, next step. Let's say we want to try and do some debugging. So I'm going to add a breakpoint on my response.send, and then I'm going to run apsody debug. What that's going to do is it's going to start LLDB server inside the Docker container. So it's going to be ready to do remote debugging from the VS Code into the remote Docker container. OK, so that says ready to debug. I can now use the LLDB plugin in VS Code to launch debugging. So let's see that. So I start debugging. That is going to run the application remotely inside the Docker container. There we go. It's running it. And if I go back to my browser and hit refresh, whoa, I hit the breakpoint locally on VS Code. That is really nice. I'm going to press pause here. This is really cool, but this is not all ponies and unicorns, I'm afraid. The state of LLDB remote is not wonderful. You can see there's a distinct lack of local variables. They don't seem to appear or work. If you disable and re-enable breakpoints, they seem to get lost. So there's some issues with LLDB remote, but I think hopefully we can make some progress on those. Okay, so that's just pressing continue. Okay, final thing I want to show you is the deploy experience, like how you actually get this app into Kubernetes. So if I do appsd stop first to stop the debugger, and then if I go up to my Docker, Docker for desktop actually has a little mini Kubernetes built into it. So you can start Kubernetes locally on your Mac, which is a really fun way to play around with it. So there, I've switched Kubernetes on. And now if I do an appsd deploy, we should see what happens. So I'm watching all the different pods on the cluster. So currently nothing deployed on the cluster. Now if I do a deploy, it's going to deploy two things for me. The first thing it's going to deploy is what's called the appsd operator. So that's like a background process that's going to run on my Kubernetes cluster, waiting for my applications to run. So there's the operator up and running ready. It's sitting in the background. The deploy now goes on to actually package up my app into a final production Docker container. To do that, it's going to build the app again in release mode. And once it's built the final production Docker image, it's then going to deploy that onto the cluster using the operator that's already running. So let's see. Build the Docker container, apply the YAML, which was generated for us, and there we go. It says we have the app running on the cluster. It's being forwarded to a specific port. So I'm just going to go to that particular port, and we can see, yeah, this time we're running in a Kubernetes cluster. That was really easy. So, okay, how do we get some of the benefits of Kubernetes here? What if we want to actually have some of that scaling failover? How do we do that? Well, let's have a look at one of the files that was generated. One of them is called appdeploy.yaml. So this is basically the metadata you need to get that deployed onto Kubernetes. So what we can do is just make a quick edit to that. And then if we reapply that to the cluster, it's going to say, oh, we need to have 5 of these things running. So there you go. We now have 5 of our container running happily in the cluster. Awesome. There we go. So I think I'm pretty much out of time. I hope that's interesting to people, that it's got a kind of live hot code reload development experience for Swift on the server. I didn't have to open Xcode once, which is always nice. We hope you find it interesting. I should stress it's not just a Kitura thing. So I was using the Kitura stack there, but there is a Swift stack as well. And I've got another demo of a Swift Neo application being deployed into the cluster as well. So it's absolutely not a Kitura thing. You can use it for any framework. In fact, there's a great blog post about using it to deploy a Vapor application as well. So if that's interesting to people, come and have a chat in the break. Thank you very much.